Good evening and welcome to the Exploratorium and to this evening's presentation of Everything Matters, Tales from the Periodic Table. I'm Ron Hipschman. I'm your host for this evening, and tonight we're exploring manganese. Not an element that a lot of people have heard about, so hopefully you'll enjoy this. Did everybody get their collectible card? Because if you did, this is important because every time you come here, you get one more card. And if you need to fill in, how many people, this is the very first time you've been to this? Okay, how many people have been to one before? Okay, if you haven't been to one before, we will actually let you fill in. There's some on the table back there to fill in your element collection. Because everybody collects elements, don't they? I did when I was a kid. Okay, I was a little unusual. But there's a whole stack of them now, so there's 25 cards. You can build it on your wall, build the pyramid. Eventually, when I'm about 75, you'll have the whole collection, I think. If you enjoy After Dark, by the way, how many people have been to After Dark before? I'm just curious. If you enjoy After Dark, you know, we have a brand new, this is commercial, we have a brand new After Dark membership. So take advantage of that, and there's all kinds of interesting perks with the After Dark membership. So, tonight, we're going to do a program that's about 60 minutes long. Excuse me, I had a cold about a month and a half ago, which is, I'm going to hack my way through this. I'm going to talk about the chemistry, the history, the applications, some of the physical properties about manganese, and then we're going to move on. I'll be followed by Suzanne Angeli. Suzanne is going to talk about the environmental exposure to manganese and how that is a potential risk factor for developing Parkinson's. Be sure to stick around for that. So when I'm done, don't go anywhere. Suzanne's going to come up after me. So that will be a really interesting talk. I'm looking really forward to hearing that because I haven't heard that one myself. So, manganese. Manganese is not magnesium. Two separate elements. We've already covered magnesium. Manganese is element number 25. Can anyone spot it? Well, it's easy. There's a 25 right next to it. It's right there. Manganese is the 25th element. 25 is its atomic number. Its atomic number is how many protons are in the nucleus. That uniquely identifies it, which element it's going to be. Because if there's 25 protons, there have to be 25 electrons, and it's those electron shells where all the chemistry happens. There's different numbers of neutrons in the nucleus, and we'll talk about that in a moment. Manganese was kind of first found in Greece, and specifically in the Thessaly region here, and even more specifically, yes, in the prefecture of Magnesia. Get it? Yes. Magnesia, which is where we get manganese. Also, there was also magnesium there as well, and also a magnetic stone that we call magnetite, which is where we probably also get the word for magnets. So magnesia has contributed quite a bit to our manganese discussion here. It's mined mainly from one mineral, mainly pyrolusite, which sort of means fire washing, and we'll get to that in a moment. Pyrolusite is manganese dioxide. It's a black, brittle mineral. It also occurs in a really pretty one, too, and I just wanted to show you that because I think this is just lovely. This rhodochrosite is manganese carbonate. Now, the first guy who kind of used manganese, he didn't actually get the element out of the mineral, but he used the pyrolusite, the manganese dioxide, to make chlorine. So if you were at the chlorine talk, which we've already done, he used this chemical reaction here where he took hydrochloric acid, mixed it with manganese dioxide, and resulted in manganese chloride, water, and, well, here's a much easier way to look at it, a chemical formula, I think, and chlorine gas. So, but he knew that inside of manganese dioxide there was some kind of new element, but he was not able to actually purify that metal from the element. It took this guy Johann Gottlieb Gahn to finally synthesize and purify actual metallic manganese, and he did that in 1774. Manganese metal kind of looks like this. It's kind of a grayish, silvery metal. Here I actually have some samples of it right here in a plastic bag. I don't know if you can see that over on that camera. Maybe we can put it up on the screen. But it's, well, it looks just like that. We don't have to put it up on the screen, but our web audience probably would like to see it. I'll pass this around for people who want to take a look at it. Feel its density. It has about the same density as steel. Oops. Okay, now we have the camera up on the screen, so I'll show you the camera now. There we go. There we go. Let me see. There we go. Manganese. Okay, we'll pass that around. Most of the manganese comes from South Africa. As a matter of fact, if you look at the actual amount of production, South Africa accounts for most of it. And then some other production also comes from Australia and China and a few other places in the world. Now, as far as its abundance in the universe, it's the 17th most abundant element in the universe by mass. If you move in a little bit to the sun, it's also the 17th most abundant element in the sun. That's not a coincidence because the sun is kind of made out of the universe. Although the sun is kind of a second or third generation star, so there are increased abundances in the sun of some heavy metals. If you look in meteorites, it's actually quite abundant. It's the 13th most abundant element in meteorites. It's the 12th most abundant element in the crust of the Earth. So it's really abundant, actually, in the crust of the Earth. It's about 0.1% in the crust of the Earth. And, but the oceans don't have a lot of it dissolved in the ocean itself, so it's only the 30th most abundant in the oceans. But there is a lot of the ore sitting on the bottom of the ocean, which we'll get to. And in human beings, it's not real abundant, 27th most abundant element in human beings, but it is essential. We do need it, so, but not too much. It's made inside of stars, both exploding white dwarf stars and exploding very massive stars, supernova. So it's not made inside of our sun. It's made in the reactions, the very hot reactions when stars end their lifetimes. When it's created in lots of different forms. Different forms of the element are called isotopes. And we can see here that manganese has a lot of different isotopes. Now the number you see up at the top, for instance here, manganese 48, is the number of protons plus neutrons in the nucleus. Remember, always 25 protons, always. But the number of neutrons can vary. Of all of these different forms of manganese, and they all would react chemically similar, because the electrons are kind of the same, there's only one of those isotopes that is not radioactive, or saying it the other way, there's only one of them that's stable, and that's manganese 55. That's the only stable isotope of manganese. So that makes up, of course, what? 100% of all the manganese. Of the other isotopes, they're all radioactive, and there are some that are longer lived than others. Manganese 53 is the longest lived, 3.7 million years. That's how long it takes for half of a sample of manganese 53 to decay. That's the half-life. And the others all have half-lives that are much less than that. But even 3.5 million years is very short compared to the age of the Earth. So in the age of the Earth, all of that radioactive manganese is gone. A little bit is made by cosmic rays, but we don't need to worry about that. So what else can we learn about manganese? Well, what's its density? Density is about 7.5 grams per cubic centimeter. Everyone remember what water is? What's water? About 1 gram per cubic centimeter. And I've listed a few more down here. You can see that manganese has about the same density as iron. Very close. It's a little bit lighter than iron, but not much. Excuse me. I have down here some samples of various things that you can pick up and experience different densities down here. So come on up after, and down here I have wood and plastic, and what else do I have? I have magnesium and aluminum and titanium and, oh, I've forgotten now. No, titanium, and then iron and copper and lead and tungsten. So, and manganese, is, as you can see here, is about in the middle of all of those, about the same as the iron brick that you see down here. So come on up and play with those after, and be very careful though if you're going to lift the tungsten brick, because that is extremely dense, very heavy. Don't drop it on your toe. It will definitely leave a mark. Unlike things like copper and gold, manganese is fairly hard. It has kind of a mid-range hardness. It's on the Mohs scale of hardness. It has a hardness of about 6. It's a little bit softer than glass. So it's a pretty hard element. Diamond is 10 on this scale. So you can see boron also near the bottom there is very, very hard as well. Manganese is, since it's not very rare, it's also not very expensive. It's about $1 a pound, so it's pretty cheap stuff. It has a big atom, though, because there's a lot of free electrons hanging out there on the outside of manganese. So the manganese atom is actually quite large compared to hydrogen, just to do a size comparison. It has kind of an unremarkable spectrum, so there's, in this case, there's really like nothing to see here. Move along. There's not many lines in the solar spectrum that stick out because of manganese, and so I'm sorry, there's just nothing to show here. Maybe I should have skipped that slide. Oh well. It does it does occur on the bottom of the ocean in these manganese nodules. And these litter the floor of the ocean in some areas. They're kind of a layered structure as they build up, but they're very high concentration of manganese in these things. If you look at the bottom of the ocean, they actually, it kind of looks, the bottom of the ocean looks like this. Those manganese nodules are just sitting there on the seafloor, about 1 to 4 inches in diameter, just to give you a scale for that. The total amount of those nodules on the seafloor is estimated at 500 billion tons of manganese. So it's a huge source, but you have to kind of scrape the bottom of the ocean to get them, so nobody's commercially doing that yet. What's it used for? Its biggest use is in stainless steel, things you're familiar with, pipes and your sink if you have a stainless steel sink, or your cookware. Those are all stainless steels, and there are lots of different stainless steels, each with different kinds of elements. Nickel plays an important part, chromium plays an important part, vanadium, some of the elements we've already covered, and a couple that we have coming up. If you look at a chart of these elements, of these different steels, stainless steels, the ones that we use most often is this one that's 304 or 316. Those are the common stainless steels, and they both have about 2% of manganese in them. But there's lots of stainless steels. So, and they all have a little bit of manganese in them. Another use, not only in alloying steel to make it stronger or less more rust resistant, is also in aluminum. And these cans that we drink out of all the time, these are have about 1.5% of manganese in them, and that keeps them from decaying with all those, if it's got Coke inside there, or it's actually always acidic if it's carbonated, so it's always going to try and eat away that aluminum, and the manganese helps keep that from happening. Another place that you'll find it is in these things. Remember these? Remember when they were called, this is not a lithium battery, or it's not a nickel cadmium battery. This is just a plain old dry cell battery, zinc carbon battery. These things, if you saw them in half, they kind of look like this. And here you see that the outer shell is made of zinc, There's an inner rod that's made of carbon, and the reddish area here is that stuff that they mine for manganese. It's manganese dioxide, but also this turns into something else. Usually when you pull electrons and protons apart, usually you get a lot of hydrogen generation. And that stuff, the manganese, keeps hydrogen from generating inside of your alkaline cell or your zinc carbon battery. So it's kind of an important component. We don't want hydrogen inside of our batteries. That would be bad. It also has been used, manganese, as a gasoline additive. Let's see if I can pronounce this. Methyl cyclopentadienyl manganese tricarbonyl. Okay, close enough. MMT. That was a gasoline additive after they took lead out to keep engines from knocking. They added this MMT in, but that increased the amount of manganese in the air instead of lead, and so that was only used until about 1977. Artistic uses of manganese. We have to go way back. Here are some cave paintings in France, and that the black color here was manganese dioxide, that pyrolusite mineral. And so cave paintings, the black in the cave paintings was often used, this manganese dioxide. Okay. There was another really cool thing in caves that they used to do. They used to take a bunch of this colorant in their mouths and spray it over their hands in the caves. This is really unusual, this one. This person had a full set of 5 full fingers and a thumb. Most of the ones you notice in the caves, and there are other slides that I don't have here, but most of their hands were not quite complete. But I didn't want to show those. Manganese is often used to remove iron from glass, so it takes the greenish color out of glass. But if you add more manganese into glass, it actually turns this beautiful color of kind of a pinkish color. Actually, maybe we can get a shot of that over on the camera for the web audience. So this is actually, I had to put a little, there we go, put a little white screen behind it so you can see that beautiful pink color. This is an antique bottle. Thank you. We'll go back to the slides to return that to the person who loaned it to me. This was Lancaster's Indian Vegetable Jaundice Bitters from Colonel Sam Johnson, proprietor, Richmond, Virginia, 1852. This stuff, let me tell you, this stuff, it cured everything. Jaundice, headache, dyspepsia, worms, dizziness, loss of appetite, darting pains, colds, fevers. It cleansed the blood of humors. And I like this one. I don't know how this worked, but it moistened the skin. Liver complaints. Now, I don't know if anyone's ever heard of this. I'm not even sure how to pronounce it. Strangery. Dropsy. My favorite word, croup. And my favorite word for this one, phthisis. P-H-T-H-I-S, phthisis. That's kind of tuberculosis, actually. Now, it does occur in the human body, as we mentioned. In the human body, it's an important element for human health. It's essential for your metabolism. It's part of your antioxidant system in your body. Your body has about 12 milligrams, 12 thousandths of a gram of manganese, mostly in your bones. But the soft tissue remainder is kind of concentrated in the liver and the kidneys, and it's a required trace mineral for all living organisms. It also acts as kind of a neurotoxin in larger amounts. Overexposure, which we will hear about, Suzanne will tell us about that, actually can cause something called manganism. So we're going to hear a lot more about that with Suzanne. She's going to come up here and talk. I just want to leave you. I just found all these really great element haikus. So the one for manganese is avoid confusion. in place of your own name, write not magnesium. So next month, we are going to have, we're going to be doing iron. That's going to be on January 18th. And I also do 2 other series of talks or coughs nowadays. One of them is we're going to have a sane discussion about radioactivity in January. Also, we're doing the very last one with Lorne Peterson, who is the chief model maker for Industrial Light and Magic. In January, we're going to talk about, he built the Millennium Falcon, but we've already done Star Wars, so next month we're going to talk about all the other movies that he's done, from Poltergeist to the Pirates of the Caribbean. So that's going to be a lot of fun. So we hope you'll come back for that. That's on Sunday, January 21st at 2 p.m. And I'd like to bring Suzanne up here and introduce her. Thank you.